This is Design Safe Radio, where natural hazards researchers strive to make our society more resilient to everything nature throws at us.
So do you guys do training for researchers who are just getting into this field and this as a technique as well?
We do. So there are different types and forms of training, depends on what you want. So let me just stop sharing this. So the first thing, if you are a graduate researcher or a collaborator that comes and uses the facility, we'll give you a special training for you of how to use the facility, how to acquire the data that you are asking for, and so on. So you definitely have your own training if you want to use the facility. We have 2 workshops per year. The first one is usually online one, where we introduce you to our facility and what we can do, how to help you write a proposal, and it's more of networking thing. And then we have an on-site workshop that has hands-on activity where you get also a training about a real-time hybrid simulation, and you get to see physically the capabilities of the facility. We host the REU program. So, and this is actually one of my favorites because it's training for undergrad students and also for graduate students. So we make undergrad students get involved in real projects, not just any research, I don't know, literature review or something. No, it's a physical experimental, and you go and you get data and you publish a paper. So they are very involved in it. And at the same time, it trains the graduate student to become a mentor. So that's also another good professional training for you. So I think I mentored 5 students, undergrads, when I was at Lehigh, which was great because if I'm becoming a faculty, that's a very good training for me.
Oh yeah, it's a really important part of becoming a faculty member is how to mentor and coach and lead a research team rather than just doing the research.
Yeah. We have also seminars. We have from 6 to 7 seminar per year where we talk about the most updated research and how we can use it in our lab. We invite experts in different fields and the most important questions, and we ask them, and also good for networking as well. And you can get a special training if you want to use something specific in your testing. So for example, I wanted to use in my subassembly, I wanted to use DIC, so I got a special training of how to get the data from DIC. So this is something that the facility also provide to us. We get training. When I was a PhD student, I got training, for example, how to use Design Safe, how to publish the data, and so on. So this is also very important. So yeah, so we have different types of training, and everyone has their own objective. Yeah, but that's it.
That's great. Kind of turning the corner into the research itself.
Yeah.
There have been a ton of really interesting projects that have gone on in the past few years as you've been a member of the Lehigh, graduate student staff there, and now as a postdoctoral researcher. What are some of the most interesting projects you worked on, and can you tell us some of those details? And if you have any outcomes or things that you learned from that would be really great to hear.
Yeah, so during my PhD, I worked on the NHERI Tallwood project. And let me share my screen to show it. And it's okay, so with the mass timber movement right now, because of how this is an eco-friendly approach, and we're trying to diminish the carbon emissions. So researchers are more interested right now with mass timber, and like in the US, like most, I don't know, maybe 90% of the structures are from wood. But if we want to build tall wood buildings, we have to understand more about the behavior of the building as a whole, right? So this was part of the NHERI Tallwood project, where we had like to build a sub-assembly, and we were like monitoring the behavior of all the components. And I'm gonna just ask you like some questions right
Yeah.
now, which will lead you like at the end to the answer why we had to build the whole thing in here.
Right.
Why not? Like, yeah. So the first question that comes in, which is very simple. Do you like to live in a damaged building?
Yeah. No. I mean, I do because I got kids and a dog, but like I don't particularly like it when things are broken.
No. So I think we've come like very successful that we can build structures that do not collapse under earthquake. Okay. But they're severely damaged.
Right.
But we don't want to, like, it has to be like this common sense. We don't want to live in damaged buildings. We just need to have maybe like minor damage or easily repaired buildings, so you can like continue your life, like, or have like a less downtime after an earthquake.
Right.
So the big picture, we don't want damaged buildings. That's it. So we want to design a building that has low damage or damage free. If we can do it, we can do it, that would be great, because we're concerned about community resilience. Okay. So usually people, when they go and want to test a new lateral force resisting system in the lab, they just take it. So for example, I'm going to take my shear wall and I'm going to load it in the direction of the shear wall, because this is where it resists the earthquake or the lateral force. Do you know the direction of an earthquake?
No.
If I'm
not completely anyway.
Yeah. So
and even if you do, your building may not be sited for it anyway.
Exactly. So even if it's not resisting at this direction, it's gonna move or deform in this direction.
Right.
So you have to test things multi-directional. You cannot just test it unidirectional. If you're gonna take your shear wall, anchor it to an actuator, displace it back and forth, is this what's happening in an actual building?
No, it doesn't tell you nearly the whole story. You just get maybe a couple of pages of the book.
because this is not going to happen in actual building, because you have the forces in the floor diaphragm that goes to the, for example, the collector beams that collects the forces from the floor diagram and then transfer it to your wall. So you have to keep track of the dots in here to understand what's happening in an actual building, because there are some connections. There are some flexibilities in the floor diaphragm. There are flexibilities in other components. So if you don't keep track of this will affect
and just like how
response.
it is constructed. Even the best contractors don't make everything perfectly because they're human, and there's differences in fasteners and adhesives and all sorts of things.
Okay, let's assume I have all of this answered. I made the best shear wall that is damage-free and everything. What about the gravity load system? I know it's only carrying the gravity load, but it's gonna also deform and it's gonna be subjected to multi-directional kinematics. Let's assume I have my wall is perfectly fine and damage-free, but everything else is damaged. It's still a damaged building.
It's still a damaged building, yeah. You got one wall standing, yay.
Exactly. So yeah, if your frame or your wall is still damage-free, but all your gravity system is just damaged, your non-structural walls are damaged, your stairs are damaged, everything, that's not a functional building.
No.
So you cannot just take your lateral force resisting system and test it in isolation. You have to include everything, especially when you are talking about a relatively new material that we don't really understand the behavior of it. So that's why we had to like build a 3D specimen that includes all aspects of a building. So it has like, you have your floor diaphragm, you have the collector beam that collects the lateral forces from the floor diaphragm transferred to your shear wall, and then you have your gravity load systems. So the main objective is that we can design and construct a damage-free or low damage structure that has all the components and the connection details that can withstand the earthquake, and at the same time accommodate the kinematics that are expected in an actual building under multi-directional loading,
Right.
because the earthquake comes in different direction. Okay, so we had to build like a part of a prototype building in Atlas, and we succeeded in that because right now it's still in there. We've tested this like, I don't know, over maybe 500 cycles or something like that, and it's still in that. So we're going to use it as a test bed now.
Right.
So a lot of collaborators, they have ideas about devices or connections, and they need a test bed that they're going to test it. So
one of the things we were talking about at AGU, like, wouldn't it be interesting to test a seismically resilient coffee shop? You know. Who wants to build an espresso machine that's seismically isolated and put it on the test bed at Lehigh? I'm with you.
So if anyone has an idea, they can just go, because it's a resilient structure, and sometimes we just need a test bed where we can test our devices in there. So that's what we are doing right now. It's like collaborators, they have ideas, they have some ideas of the dampers or force limiting connections and so on, and then they're gonna add it to the specimen and test it.
And again, this just shows like the power and the necessity of the NSF's investment in the NHERI network. Like, we did the full scale 10-story amazing flagship test at UCSD, and we use that data now on a very much smaller footprint test bed at Lehigh, but it still has the full fidelity of that test of, you know, with the real-time hybrid simulation for anything that you want to put in there. And you don't have to have a whole 10-story building anymore to do that.
Yeah, exactly. So that's the and also I want to mention, like, I was very privileged to work in this type of testing because
Thank you so much. Where could people follow along with your research and what your team is doing at Lehigh as you keep doing these really amazing tests?
So we always publish on like LinkedIn, Twitter. Yeah, I think LinkedIn and Twitter mostly. Either our like personal pages or the university page. So this is where and also whenever there's something cool, we either email Marty about it to publish it, or also if we have something, we also publish it on Design Safe, announce it on Design Safe. So these are the places where you guys can and you can definitely like go to our website and shoot us an email like really quickly. We can talk, even an informal chat. Like, I always encourage anyone, just we can have an informal chat. If you don't have to have like anything written perfectly or anything, just we can talk. That's it. So
excellent. We'll be sure to post links to that in our show notes. Alia, thank you so much for your time today. It's just been really, really wonderful getting to know you a little bit and about your research and getting reacquainted with the Lehigh facility. It just, everything there is always so inspiring, and really appreciate your work.
Thank you.
Hopefully we'll get to chat again sometime soon.
Yeah, hopefully. Thank you so much. Thank you for having me. Have a great day.
Thanks.
Thanks for listening to today's episode of Design Safe Radio. Be sure to like and subscribe on whatever platform you happen to be listening to this on. It really helps people find our show. Thanks to our amazing sponsors, the National Science Foundation and the NHERI Network Coordination Office, which is award number 2129782. Big thank you to Marty LaChance, our guest booker and topic researcher extraordinaire, and Raquel Ruiz, who is our video and audio editor. I'm your host and NHERI Facility Scheduling and Operations Coordinator, Dan Zahner. We'll see you in the next episode. Until then, stay resilient.